In this video, you will get to create your very first scripts with Godot and the GDScript programming language. We'll start by making a character turn in circles, and then we'll add input support to make it a nice little toy, kind of ship moving forward, or in that case, really the Godot head. This is for programming beginners. Well, going to write only a few lines of code, and I'll run you through all the instructions. Now, don't expect to know programming after 15 minutes. It will take much more time than that. And perhaps some of those things will be a bit challenging. Like you might not remember everything at the end of the tutorial. But the point is to have you write concrete code that already leads you to game creation. You will be rehearsing, reusing, and building upon this knowledge in the upcoming videos. This is part of a complete free series to get started with Godot in 2021. If you haven't already, I invite you to watch the series from the start. You'll find a link to it in the description below. With that, let's get coding. Let's get started by opening Godot, and we're going to create a new project starting from a clean slate. So I prepared an empty directory, which is a requirement for your projects. I'm going to paste the path in the project path here. Also set it to OpenGLES2 as it's compatible with more laptops and things like these. We end up on the 3D view, but we want to create a 2D game. So we're going to create a scene with only a sprite node. I invite you in the scene doc to click on create an other node, and we're looking for sprite here. So you can type it and press enter to create the sprite. Currently, the sprite has no image and it's stuck in the top left corner of our viewport. So we're going to select the node, and to assign an image to it, we drag the icon.png image file onto its texture slot. Now Godot will appear. With the select tool selected, it's this one in the top left of the viewport, we're going to click and drag on the character to kind of center it in the view. All right, so that's our scene setup done. Now we can attach a code to that sprite node that's only displaying an image to animate it. To do so, we first need to save the scene. So we're going to press Ctrl S, or you can go to Scene, Save Scene, and we'll save it in this empty directory, our project root, as sprite.tscn. You can see it appears here. Okay, so with that, we can add a script to our sprite. To do so, you can select the node and an icon appears in the top right of the scene doc. You can also right-click and select Attach Script. This opens a little pop-up that gives us a few options as to how we want to create the script. First, the programming language. We'll use GDScript, the default. The inherited class, by default, this will be the type of the node you created. That's what we want. The template, by default, it's default, which has a little bit of boilerplate code. You can create template files that you can build from. If you reuse a certain structure all the time in your code, you'll want to create a template. We'll use the empty one, which is, as the name suggests, empty. Built-in script allows you to save the lines of code inside the tscn file we created. The default, however, is to create a separate file, in this case sprite.gd, which is what we want here. So we'll click create. This takes us to the script editor. And first on the left, you can see the list of open script or documentation pages. Should also mention that you can use Ctrl-Shift F11 to expand the script editor. And you also have a button to do so in the top right of the script editor here. The first line, extend sprite, tells us that the script has access to all the features built in the engine on the sprite class or type. You can control-click on the name to open its documentation page, right? The code reference. Sprite inherits from 4 other classes, so it also has all their features like that of Node2D, the position, rotation, and scale. And it also has all the ones defined and listed in this page, the properties and functions, also called methods in that case. All right, so I'm going to right-click on it to close the sprite page and we can get coding. We want to move our character smoothly on the screen. And to do so in a game engine, we have to update the sprite every frame. A game runs in a loop with, by default, 60 images calculated per second. And the way you move something is every frame, every 1/60th of a second, you move the character a little bit. To do that in Godot, you have a function built in that's called process, and you use it to tell the engine, this is how I want to update my character every frame. We define a function with the func keyword, and then you want to type the name of that built-in function, process underscore process. You will have an auto-completion suggestion that appears. You can press enter to accept it and save some typing. When you press enter, you see that the cursor returns not at the start of the line, but after one tab character. In GDScript, tabs are really important. They define blocks of code. So when you define a function with a colon at the end, you then need to add one tab, one indentation level for Godot to know that this is the body, this is the instructions of the function. If you don't do that and you try to type some code like rotation plus equals 3, for example, you will get the red line that appears and stays and an error at the bottom that says indented block expected after declaring the function. This means that your indentation level is incorrect. So you need to add a tab by pressing the tab key at the start of the line and you'll see the error disappears. All right, first, we're going to make our character rotate. So we can add a very little value like 0.05. And so to add some angle to the rotation, we first type rotation to access the rotation property. Then we can write equals rotation plus 0.05 or use the shortcut I used before, write plus equals. Why that value of 0.05? It's because rotation is in radians in the engine. Radians are based around the number pi. 2 pi radians represents 360 degrees. Okay, once you've done that, you can press F5 and we have to define the main scene for our application. So we can select sprite.tscn, double click and run it. And you'll see the character turns. That's a start. Now, that hard-coded value is not ideal. We might want maybe something a bit more descriptive than 0.05. To do so, we can define a variable or property. These properties, you define them outside of those functions, typically at the start of your script. You can define one using the var keyword, and you can start to see a pattern where built-in keywords are in red by default. After that, you name the variable. In that case, we're going to call it angular underscore speed. And we're going to use the equal sign to define a value. So our angular speed will be, we could say 3.14. This is an approximation of pi. Or you have the built-in constant pi. The constants that are defined in the GDScript language are written in red. And this in the game, when it runs, will be replaced by a value, 3.14 and lots of decimal numbers after that. So now we can replace this line by pi. And as our value is now a speed, its units are radians per second. And we want to multiply this by a time value to turn it into a delta rotation, a rotation this frame. You can notice that the function process has something in parentheses. It's called an argument. It's a value that the function receives. In this case, delta is the time interval between two frames, and you can use the value to make your code time dependent. So in here, we're going to multiply pi by delta to turn our value into a rotation offset we want every frame. Why does that matter? Because the time between two frames is not equal. It changes a little bit from frame to frame. So by using the delta value, we ensure that the rotation is consistent and depends on the time that elapses in the game rather than being applied per image. In particular, you've seen when games slow down, if you don't use that delta value, everything will start to move slower. You can now press F6 to see the character still rotates roughly as before. Okay, so now we want it to move, and to do so, we can change the character's position. So we can type position. Again, we want to add to the position, so we say plus equals, and then the position uses the type vector2. It's a vector with an X and Y component. We want to add a vector2 to it. Actually, we must add one. To do so, you type the type vector2, and you open parentheses to create a vector2, and then the engine tells you you need an X value. It's a float, in other words, a decimal value, and you need a Y value, also a decimal value. So we could say 1.0, 1.0. Every frame we add that, and we're going to see F6, the character now moves down diagonally. So note a convention, it's that the x-axis is positive to the right in a game engine, and the y-axis is positive going down. That is unlike what you saw in math, where the y-axis points up. So you have to keep that in mind. So now, once again, we can turn that into a speed. To do that, we're going to use bigger values in here, like 100 and 100. You could think of it as a value in pixels per second. And then we're going to multiply that by the time delta. Then the character moves still diagonally, but now we don't have that frame dependence problem. It's now time dependent. Next up, we're going to change that a little bit. We're going to use a speed property. So we're going to name the thing that moves the character speed. To do that, we go back to our angular speed here, and we add a line return, and we're going to write a new variable named speed. We're going to set it to a value of, you could say, 400.0, 400 pixels per second. It's not a vector, right? So now we're going to change the code that updates the position a little bit. Instead of having a hard-coded vector, we're going to use one of the vector2 constants that exist in Godot to have a direction, which will multiply by our speed, which will multiply by the delta time. This is a more appropriate way of calculating move direction in games, as you'll see moving forward. So to do this, we first select everything you had here. You're going to delete it, and then type vector2 dot. We're going to access the properties that are defined in the vector2 class. And you can see that you have a few, so axis X and Y. You have down, left, right, up. You can use the up and down arrow key to navigate these suggestions. And we're going to select the right vector, so the character will move to the right. We'll multiply it by speed times delta. So just to show you here, vector2.right is equal to a vector2 with a value of 1.0 on the x-axis and 0 on the y-axis. But it's a bit nicer to have a name for it, right? It's the same for speed. The point is to understand the meaning of the code while writing and to help your future teammates also read your code. So this will make the character move to the right. Now we're going to go one step further and have the character turn. I'm going to create a new variable inside of the process function. For that, we write the var keyword and a name. Once again, we're going to call it velocity. This variable is different from the ones outside the functions. The ones outside the functions, we call them properties because there are values attached to our sprite script and that are available in any function. But when you write a variable inside a code block, like our function, then it becomes a local variable. It is a value that's only available within that scope. The velocity here is only available in the next lines, like when we change our position. We're going to set it to vector2.up. So we're going to start with the up direction. It's a vector pointing up. And we're going to rotate that vector. To do that, the vector2 class, if I go to its docs page, if it wants to open, I'm going to click on methods in the right side to jump to the node's methods and scroll down a bit. We're going to use this one, rotated. The function is going to take an angle and it's going to return a new vector rotated by that angle. Let's go back to the sprite script. To call a method on a given object like our vector2, we add a dot and we type the method name. So this one is rotated. Again, can press enter to complete. And then we need to pass an angle. This angle will be our rotation. This will allow the character to move in the direction it is looking. We'll see why in a second. And I'm going to multiply that by the speed value. For now, we're just calculating that value and storing it in a container or assigning it the label velocity. It's not moving our character yet. To do that, we have to replace the calculation here. We'll add the value of the velocity variable to it, multiplied by delta. To explain that, why we call it velocity, why we multiply it by delta, a velocity is a vector that represents a direction and a speed together. To then turn that into a motion every frame, we have to multiply it by time value. So the velocity is going to be in pixels per second, and we multiply it by a value in seconds to turn it into a position offset. So you can try now to see your character turned in circles. You might be a bit puzzled about this part, why it makes the character rotate. It's because every frame we increase the character's rotation, so we change it. Then we start from a vector pointing up and we rotate it by the current rotation. And as its rotation, its angle is changing, it's looking in a different direction, so it will move in a different direction. That makes it move in circles. Okay, so now we're going to introduce input. We're going to listen to the keys pressed on the keyboard and make the character only move if the player is pressing a key. Let's start with the rotation. So first I'm going to turn the two lines that move the character into comments by selecting them and pressing Ctrl K. You can see a dash sign gets inserted at the start of the line and they become grayed out. They will not run anymore. Then we'll start with just the rotation. So to do so, we're going to first define a variable. We'll call it direction, and it will start at a value of 0. And what we're going to do is we're going to use conditions. If the player is pressing a key, then we will change the direction and we will use it when adding our rotation. You'll see how in a second. But first, let's see how we listen to input in Godot. I'm going to show you one way today. We start by defining a condition with the if keyword. Then we write the condition. The condition is going to be input, a global object available in Godot that has many methods. One of them is action pressed. This is the one we maybe use the most in Godot, and it takes the name of an action, many of which are defined by default in Godot, like UI accept, it's for when pressing enter or A on a gamepad. But the ones we're looking for are UI left. In that case, we're going to start with that one. Navigate down to UI left and press enter. To define a condition, we write if, the condition to evaluate, and then a colon at the end. And we're going to press enter, which will create a new block with 2 indentation levels. Everything that's at 2 indentation levels like that is going to run only if this condition is true. So only if the player presses the UI left action, which is the left arrow key by default. In that case, we're going to change the value of the direction variable. To do that, we type the name direction with an equal sign and we write the new value. And it's going to be -1. So we'll consider going to the left is a value of -1. I'm going to add the other condition to move to the right. Then we'll explain how that works. Okay, so if input.is action pressed, and then we're going to go with UI right. So we look for UI right at the end of the list. In that case, we're going to set the direction to 1. So direction will be 0 by default. If the player presses the left key, it's going to be -1. If they press the right key, it's going to be 1. And then what we can do is when changing the rotation, we can change this by angular speed, times direction times delta. So it's going to be this value multiplied by this value, 0, -1 or 1, times delta. Now, if we're not pressing left or right, the value of direction will be 0. So we'll add 0 because of the multiplication by 0, giving you a value of 0. In that case, the character will not rotate. You can already test it by pressing F5. The character does not rotate. If you press the left key, it rotates left. If you press the right key, it rotates right or clockwise. Now, this if keyword, I told you it's going to evaluate what's after it. A condition uses an expression that evaluates to either true or false. You can see they are in red because there are core values in most programming languages called booleans, true, false. And so luckily that function input.isActionPressed returns true or false. So at runtime, this is going to become either true or false every frame when it's evaluated. If we press the left arrow key, this becomes true, and so this line of code runs. Otherwise, it is false, and this line of code does not run. All right, now we're going to use another input key to make our character move forward if we press the up arrow key. To do so, I'm going to remove the comments here. So I select the 2 lines and press Ctrl K. And what we want to do is do something similar. We're going to remove the var keyword in front of velocity and define it first with a value of vector2.0. So we type variable velocity equals vector2.0. We have to remove the var keyword here, otherwise we'll get an error. We already defined the variable velocity. We can't do that twice. Okay, it starts at 0. Then we're going to use a similar condition. So how is it going to look here? We want to check for pressing the up arrow. You can pause and try it for yourself. The condition is going to be if input.isActionPressed UI up. We have to look for that one, UI up. We place a colon, and then we're going to take our line, velocity, and at the start of the line, we press tab to move it into the condition block, like this. In other words, by default, our velocity will be a vector that looks like this. So vector2.0 corresponds to a vector2 with the values 0, 0. And if we press up, then we replace that value with our vector that moves the character in the direction it is looking, and we add velocity times delta to our position still. So you can press F5, and if you don't do anything, nothing happens. You can turn left and right keys and press the up arrow key to move forward at your defined speed, and you can combine it with the left and right arrow keys, and that gives you a moving character. Okay, so this was your first script, and that's a lot to take on at once. You're going to learn more moving forward, and you're going to rehearse and rehash these things we saw here in many different times in many different contexts. So don't worry if you don't remember everything at once. It really takes time. Now, I just want to show you one thing, is where these UI left, UI right, and UI up come from, and how you can see the list and even add your own. These are part of your project settings, so they are per Godot project. To see them, you go to the project menu, project settings, input map, and then you have the list. You can see UI accept, UI select, UI cancel. If we go down, we have UI left, right, up, and down. And so with this interface, you can define a new named action by entering its name. So for example, we could name one jump, and then we click add or press enter, and it gets added at the bottom. But by default, it is completely empty. So you have to click the plus sign to add a key. Joystick, joy button is a gamepad button, like the X, the cross, the square, the triangle on a PS controller, for example. Joy axis, mouse buttons. So we can add a key here, and then you can press the key you want to add and click OK. So we can jump when pressing space. We can add more as well, like a joy button. And by default, it will be the cross, Xbox A, Nintendo B. So we can click add here. And so whenever you press space on the keyboard or A on an Xbox controller, this input will be considered pressed, which you can check with the input.isActionPressed method call. And that's it for this video. That was a lot to take on, but at the same time, I wanted your first script to be something concrete. It's almost a game character, right? That could be in a game, moving, collecting things on a map. So you can pat yourself in the back for already doing this, and we'll do much more in the upcoming tutorials. If you like this video, first subscribe because there's more coming, and then we have a complete free series on our website. It's complementary to this one. All you have to do is click the link in the description, you enter your email, and you'll get lots of game development insights. Again, completely free. You can unsubscribe anytime. The link's in the description below. But with that, I want to thank you kindly for watching. We'll see one another in the next video to talk about Godot's signals. See you then.